In this module, we'll be focusing on number of factors of positive integer. In how many ways can I express a positive integer as a product of two numbers, sum of factors, product of factors, and the likes. We'll start with what are the factors of 48. It's a good way to start this entire module. Let's list down the factors of 48. Start with 1. The moment you write a 1, write its equivalent pair, which is 48. Always list down factors in terms of in pairs, so it makes it easy. 2, it's going to be a 24. 3, you quickly list down a 16. 4, 12, 6, and 8. Right. Now that we got all these factors listed down, the number of factors for 48 is going to be 10 in number. We'll count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a very, very good way to find out the number of factors, because in any of these standardized tests, no one is ever going to ask you how you got the answer as long as you got the answer right. Just put this down in a typewritten form. Number of factors, I'm just listing down the factors: 148, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So it counts up to 10 in number. Not that this is a bad method or you cannot use it. We'll look at an alternative method primarily because there are quite a few questions that you'll be able to solve better if you understand the basis of the alternative method. As with anything in number theory, alternative methods always start with prime factorization. That's what we're going to do with this number. It's prime factorized 48. Here is the prime factorized value, 2 power 4 into 3 power 1. I'm not going to delve into this process because we have done it in an earlier lesson. If you're rusty about it, please visit the essential practice. You need to iron this out as early as you can. You need to be able to prime factorize numbers in a jiffy, right? Let's move on from here. The power of 2 that can divide, the highest power of 2 that can divide 48 is a 2 power 4, because 48 is a 2 power 4 into 3 power 1. So any power of 2 greater than 2 power 4, get 2 power 5, 2 power 6, all of these cannot divide 48. We'll take a minute and list down powers of 2 that can divide this. We know the highest power of 2 that can divide 48 is a 2 power 4. Let's just list down all powers of 2 that can divide 48. Obviously a 2 power 4 will divide it. Anything less than 2 power 4 will also, 2 cube, 2 square, 2 power 1, all of these will divide. Just reiterate this question once. What powers of 2 that are integers will divide 48? That's a question. All of these are integers. 2 power 1 to 2 power 4 will divide it. That's 4 powers of 2. Have you missed out anything in the process? You missed one number, and that's 1. Just 2 power 0. Anything power 0 is a 1, which obviously is a factor. Is it a power of 2? Certainly yes. So including 2 power 0, how many powers of 2 can divide this number? It's no longer 4, it is actually 5. So if 2 power 4 is the highest power of 2 that can divide 48, then the number of powers of 2 that can divide 48 will be a 5, which is 1 more than the highest power. That 1 more is to account for the power of 0. Let's repeat this exercise for powers of 3. The highest power of 3 that can divide 48 is a 3 power 1. So 3 power 1 certainly will do it. Is there any other power? 3 power 0 will also do it. So how many powers of 2 can divide it? Which is equal to 2 in number. Now look at it. There is no factor of 2 or no power of 2 that's in common with any power of 3. That's the beauty about prime factorizing these numbers. Any factor of 48, because the only prime factors that 48 contains are 2 and 3, cannot have a prime factor other than 2 and 3. Other way of stating this is, any factor of 48 will actually be some permutation of powers of 2 and powers of 3. Let's just randomly pick something. Let me take a 2 power 0 into 3 power 1. 2 power 0 into 3 power 1 is actually a 1 into 3, which is a 3, which is a factor of 48. Pick something like 2 power 3 into 3 power 1. 2 cube is an 8, 3 power 1 is a 3, 8 into 3, 24 is a factor of 48. So factors of 48 are nothing but permutations of powers of 2 and powers of 3. How many powers of 2 are there? We know there are 5. 2 power 4, which is 4 plus 1, 5. How many powers of 3 are there? Which is equal to 2. I've just listed all these permutations in the next slide, so that we get a good idea about what we have said. These are the 10 factors of 48. Look at these. All of these 10 are some permutation of a factor of a power of 2 and a power of 3. 2 square into 3 power 0 is a 4. 2 cube into 3 power 1 is a 24. Anything you pick here will be a power of 2 and a power of 3. So using this method, how do we find out the number of factors? The number of factors of 48 is nothing but the number of ways or the number of permutations of the powers of 2 and the powers of 3. How many ways can they permute is going to give you the number of factors that 48 has got. In how many ways can they permute? Powers of 2 are 5 in number. Powers of 3 are 2 in number. So they permute in 5 into 2, 10 ways. Let's quickly derive a formula based on this. If a number n can be prime factorized as a power p into b power q into c power r, where a, b, c are its prime factors, then the number of factors for this number will be p plus 1 into q plus 1 into r plus 1. This extra 1 in each of these cases has been added. We've incremented them to account for the fact that the power of 0 of each of those prime factors is also a factor of the number, right? So it's always increment the power by 1, multiply it, that gives you the number of factors. We'll pick a couple of examples to get practice. We'll find the number of integral factors of 72, 168 and 360. We'll prime factorize these numbers. 72 starts as an 8 into 9, 8 is a 2 cube, 9 is a 3 square. We're going to increment these powers. 3 incremented becomes 3 plus 1, which is a 4. 2 incremented, 2 plus 1, which is a 3. So 4 into 3, 12 factors is what 72 has got. 168, we'll start it off as a 21 into 8, right? So 168. 21 is a 3 into 7, 8 is a 2 cube. Let's increment each of these powers. 1 plus 1 is incrementing this power. 1 plus 1 is incrementing this power. 3 plus 1 is incrementing the power of 2. So this essentially translates to 2 into 2 into 4. The number 168 has got a total of 16 factors. Lastly, 360. Quickly I can think of it as a 36 into 10. 36 is a 6 square. 6 is not prime, so we can write it as a 2 square into 3 square. A 10 can be written as 2 into 5. So this translates to 2 cube into 3 square into 5 power 1. Let's increment all the powers. 3 plus 1 is a 4. 2 plus 1 is a 3. 1 plus 1 is a 2. So 4 into 3, 12 into 2, 24 is the number of factors for 360. Right? Take a minute, try all of these things yourself. In fact, if you played the video without trying it yourself, go back, pause it, try it, check with the video and then proceed.
Check out the related videos and remember to subscribe to the channel. What's more, let's make scoring Q51 GMAT a reality. Sign up for the most comprehensive and affordable online GMAT quant course at gmat.visaco.com. That's again gmat.visaco.com.